Imagine standing on the surface of Mars, the red planet, and taking a deep breath. The once thin, hostile atmosphere has been transformed into one that supports human life. The sky, still touched with its distinctive red hue, is now safer to look at without a helmet, and the air is breathable. A mix of oxygen and other gases has been carefully introduced over decades. The transformation is subtle yet profound, though not nearly enough, as the red planet remains a barren husk of a world, forever an inhospitable hellhole to everything but the most hardy of life, confined to be nothing more than a glorified boot camp for Helldivers and a ship fabrication yard. Canonicity Advisory. This video deals with speculation. Helldivers 2 is a live service game. The continuity is always developing, and contents discussed may be disproven or made redundant by the time you view this video. The importance of terraforming in a growing regime. Let's start simple. Terraforming is the process of deliberately modifying the atmosphere, temperature, topography, and ecology of a planet or a similar celestial body like a moon. Of course, there are prerequisites to be considered before terraforming, most important of which being, does the planet possess a magnetosphere? The magnetosphere, more commonly known as the magnetic field, is an invisible barrier produced by a planet's core that disperses solar winds before they can reach and harm the planet's atmosphere. This is induced by the dynamo effect. The Earth has an inner solid core and an outer liquid core. Together, they fulfill the necessary requirements to generate a magnetic field. For demonstrative purposes, we'll be using Super Earth as the example to describe the dynamo effect. Earth has an inner solid core and a liquid outer core composed of magma. As heat flows from the inner to the outer core, it generates currents in the outer core's liquid, driven by the planet's rotation. Eventually, this current generates a magnetic field, granting Earth its magnetosphere. The more active the inner and outer cores are, the more potent the magnetic field will be. Like a lot of things in life, too much of a good thing is bad. An overactive core can have several negative effects on a planet, including an increase in earthquakes, volcanic activity, and climate change. A planet that has matured over hundreds of millions or billions of years has expended a lot of heat and is less prone to being disrupted, while a planet that is too inactive will lose its magnetic field and fall victim to cosmic radiation. Mars is the first planet that comes to mind when discussing the absence of a magnetic field, with scientific inquiries putting it as far back as 4.2 billion years ago. Mars still has an atmosphere, but after 4.2 billion years of relentless exposure, it has thinned to a fraction of its former self. With the intervention of humanity in our juvenile steps terraforming, the atmosphere was reinvigorated, and today, you could walk on its surface without dying from radiation or asphyxiation. And however rudimentary, there's even plant life taking root. But despite all of this, Mars is still an uninhabitable hellhole. Same can be said for Fenrir 3, a moon constantly under assault by meteorological events, but boasts an atmosphere strong enough to germinate crops, a truly bizarre sight only possible under the indelible wit of managed democracy in the Ministry of Expansion and Science. Fenrir 3 is a moon in orbit of the blue gas giant pictured here. We cannot ascertain the size of this moon. Regardless of whether we know what the size of Fenrir 3 is, we know that Earth is 53% larger than Mars, but despite this significant mass difference, Mars's gravity is, for a lack of better words, Earth-like. Gravity is one of the fundamental forces of nature, and it plays a crucial role in shaping the universe as we know it. At its core, gravity is the force of attraction between two masses. The more massive an object, the stronger its gravitational pull. When it comes to planets, gravity is the invisible hand that holds everything together. It's what keeps planets in orbit around stars, moons around planets, and creates the conditions for stable atmospheres. The mass of a planet directly influences its gravitational strength. determining how strongly it pulls objects towards its surface. But this is, of course, old science, a long debunked theory. If it were real, that would make Mike 200 pounds on Earth and 75 pounds on Mars. That's as much as a commercial bag of cement you can purchase from a hardware store. Due to the first colonial regiment not having any Helldivers stationed on Earth, all of my colleagues have assured me that the footage being shown now on Mars is accurate to what would be experienced on Earth if performed similarly. Mike is a very real person, and he's about to demonstrate that he is still 200 pounds on Mars. I'm not going to sugarcoat it. Jumping from that height on an old science Mars still isn't going to be a good time, as you still generate velocity from falling. But that was the sort of fall that pops lungs and breaks necks. It's by our good grace that Mike was still in good enough condition to be dropped behind enemy lines. Alright, so to recap, we have established that a potential candidate for terraforming requires a magnetic field. Without a magnetic field, life cannot flourish. It requires a stable core. Planets with unstable cores are volatile, with hazardous tectonic activity. We would have had to establish gravity, but disproven by super science, it is no longer a concern. And lastly, distance from the star, commonly referred to as the Goldilocks zone. This is a simple concept to understand. The distance from the star determines the median surface temperature. There are exceptions to this rule, like Venus being hotter than Mercury, despite being further from the sun. But this is caused by Venus's thick atmosphere, made up almost completely of carbon dioxide. This results in the greenhouse effect, allowing the Earth-like planet to capture heat. The Milky Way galaxy contains about 200 billion stars. Scientific estimates suggest that about 20% of these stars might have planets located in the Goldilocks zone, where conditions could support liquid water and possibly life. This zone is neither too hot nor too cold. By multiplying the total number of stars by the fraction with planets in the habitable zone, we determined that there could be around 40 billion Earth-like planets in the Milky Way. This is not accounting for planets with stable cores and magnetic fields, but simply, we are going to assume that a quarter of these planets have the other requirements for colonization. That's still 10 billion Earth-like planets. And there you have it. The prerequisites to terraforming a planet. We've delved into the essentials needed for a planet to qualify for terraforming and eventually colonization, from determining the activity of a planet's core and the correlation that shares with the magnetosphere, gravity, and the importance of the Goldilocks zone for liquid water. But this is just the beginning. In our next video, we'll take a closer look at the actual process of terraforming a specific planet, diving into the detailed methods, challenges, and incredible scientific innovations involved. Thank you if you made it this far, and a special thank you to those returning viewers and current members of the First. Consider liking and subscribing. If you'd like to contribute, this is the way to do it. For those who are interested in joining a developed Helldivers 2 clan, the link can be found in the description below. Events are hosted weekly. Thank you all again.